How drones work with AI in depth. Core components of AI-enabled drones. Sensors. Drones are equipped with multiple sensors to perceive their surroundings. Cameras, RGB, thermal, multispectral. LiDAR, light detection and ranging. Ultrasonic sensors. GPS modules. IMU, inertial measurement unit, for orientation and acceleration. Processing unit, onboard AI computer. Modern drones have powerful processors, like NVIDIA Jetson, Qualcomm Snapdragon, that can run AI algorithms directly on board for real-time decision-making. Communication modules. For transmitting data and receiving commands, drones use Wi-Fi, 4G per 5G, or satellite communication. AI technologies used in drones. Computer vision. Using deep learning models, CNNs, convolutional neural networks, drones can analyze images and videos to detect and classify objects, track moving targets, or understand terrain. Example, detecting cracks on a bridge during inspection. Sensor fusion. AI combines data from multiple sensors, camera plus LiDAR plus GPS, to create a more accurate and reliable picture of the environment. Reinforcement learning. Drones learn optimal flight strategies by trial and error, improving navigation and obstacle avoidance over time without explicit programming. Natural language processing, NLP, sometimes. For drones that interact with humans via voice commands or text input. How AI enables autonomy. Path planning and obstacle avoidance. AI algorithms continuously analyze sensor input to create flight paths around obstacles and avoid collisions in dynamic environments. Simultaneous localization and mapping, SLAM. Drones use SLAM to build a map of unknown environments while tracking their own location within it, essential for indoor or GPS-denied areas. Target tracking. AI identifies and follows moving objects such as vehicles, people, or animals autonomously. Example AI models and algorithms. YOLO, you only look once. A fast object detection neural network often used for real-time recognition. Deep reinforcement learning. Models that learn complex behaviors like landing on moving platforms or navigating through forests. Kalman filters and Bayesian networks. Used for sensor fusion and predicting drone position and velocity. Typical AI drone workflow. Data collection, sensors capture raw data, images, distance, GPS coordinates. Data preprocessing, AI filters noise, aligns sensor data, and prepares it for analysis. Perception and detection, AI models detect objects, classify scenes, or identify points of interest. Decision-making based on analysis, AI decides on next actions, example, change route, hover, land. Action execution, flight control system carries out AI commands in real time. Applications in detail. Agriculture. AI-powered drones map fields, detect crop diseases, estimate yields, and automate spraying with precision. Infrastructure inspection. AI detects cracks, rust, or anomalies in structures like wind turbines, bridges, and pipelines. Environmental monitoring. Tracking wildlife populations, monitoring deforestation, or measuring pollution using AI image and sensor analysis. Disaster management. AI drones assess damage post-disaster, find survivors, and deliver emergency supplies. Military and security. Autonomous reconnaissance, surveillance, and threat detection using AI-driven pattern recognition. Summary. AI makes drones smarter and autonomous. Enables real-time decision-making and learning. expands drone use cases across many industries. Thank you.